Are you like me and love to decorate for Halloween or just about any festivity? I love using automation for props. A couple of years ago, we started creating a series of how-to videos for Halloween props that we had built for a haunted house here at Automation Direct. The videos were a hit, and now the series has grown into creating a simple automated prop for every year to show you how easy it is to build when using Automation Direct products. Now follow along and watch in this video where I show you how to build a prop we call Monster in a Box. This year, we had ideas of our own, as well as searched the web and came up with a cool prop to design, build, and use for our video series. Now, while searching, I noticed that a lot of professional prop shops are now selling DIY automation controls and pneumatics. I was shocked at the cost these shops are charging for simple pneumatic products and one or two input and output devices, which are nothing more than programmable relays. I encourage you to look at Automation Direct's Nitro Pneumatics and our PLCs. Our prices are much better, and using a click PLC like this one gives you more inputs and outputs, free software, and much more room to expand. In this video, I'll explain how to build a completely programmable automated system that you can build on a budget and can tailor to your needs or application. This monster in a box could be a zombie, a werewolf, or any creature you choose, and the box could be built as a coffin or any shape or design. A lot of examples on the web used wooden pallets for the crate. But in order to speed up the build process, I ran out to the local big box shop and purchased 1x4s, a box of screws, and some hinges, and built this wooden box that represents a shipping crate. It measures 30 by 24 by 18 inches tall. Now, what we want to accomplish with this prop is a person walks by and trips a sensor, telling the PLC to control up to 3 pneumatic valves. The first valve actuates a cylinder that bounces or shakes the crate lid. This is our monster wanting to escape from the crate. The second valve controls a longer cylinder that quickly opens the lid, and the third valve and cylinder pop up our monster head. Now, once the monster head pops up, you scare the daylights out of your guest. We return all of the cylinders back to the closed position and reset the sequence. Now, the lid shaker could run continuously or only actuate when someone trips the sensor. The same goes for the lid opener and the head. We could have had it pop out randomly or in a timed sequence or when someone trips the sensor. It's all up to you. That's the wonderful thing about a PLC. You program it how you want it to control your devices. As mentioned earlier in this video, we're using a click PLC. Here I have a DC input with relay output click part number C0-00DR-D. There are several models with DC in, AC in, DC, AC, or relay outputs. It all depends on what you have connected to the PLC. All I have is a DC sensor for input and 3 DC pneumatic valves. I could have used an all AC voltage system, but I chose to work with low voltage DC with this system. Once again, when it comes to electricity and wiring, if you don't have the skills or knowledge to work with electricity, we suggest hiring or finding someone that does so you and your system remain safe. I have a Rhino DC power supply that powers the DC photo sensor and our DC pneumatic valves. I'm using pre-wired solenoid cables that we sell here at Automation Direct. They are part numbers SC11-LS24-3 and -3R. I highly recommend getting these cables or using some sort of surge suppression. These pneumatic valves have coils, and coils can create a voltage spike, and without surge suppression, your PLC or other devices could get damaged. These cables have built-in suppression, so no need for external diodes. Plus, it saves us wiring time, which time is money. These are inexpensive, easy to use, and will save you money and headaches in the long run. Since we have a 120 volts AC supply voltage, we need to use this Click power supply because the Click PLC requires 24 volts DC to operate. You may be thinking, why didn't we omit this part and just power our Click PLC from the main 24 volts DC Rhino power supply? Well, we could have, but it's not good practice to have your control power and I/O power on the same source. It's recommended to separate the two so you're less likely to have voltage noise and spikes on your PLC power. This keeps the PLC happy and operating well. We chose to use 3 different valves with this project. We have a 3-way 2-position poppet valve for the lid shaker. I used a 4-way 2-position valve on the lid and a 3-way 2-position spool valve on the head. The poppet valve controls a small spring return cylinder that we want to extend and retract quickly. I'm using a 1 1/16 inch bore 12-inch stroke cylinder on the lid, and I'm using a 3/4 inch bore with 10-inch stroke cylinder for the head. I chose the 4-way valve on the lid and did not plumb the return side of the air cylinder. I used a flow control valve and just release the pressure into atmosphere and adjust the flow so that the lid closes slowly by using its own weight. The valves are all plumbed with flexible 1/4 inch tubing and are push-to-connect nitro fittings. Each valve is wired to an output on our PLC, and I used Y1, Y2, and Y3. I chose a plastic housing photo sensor, part number QMR8-ON-0A. This DC photo sensor has a sensing distance of 1.5 meters and does not require a reflector or a 2-part sensor with emitter and receiver. The sensor is wired to our X1 input. It's the only input we have. Since I have a Click PLC, I could use it to control many props, so keep that in mind. This PLC can be expanded by adding I/O cards to incorporate many inputs and outputs and program to run several props or devices all at the same time. Next, let's turn to the software. Again, our Click PLC programming software can be downloaded for free from our Automation Direct website. In this program, I have the sensor on our X1 input. When it turns on, I set an internal contact. This contact triggers timer T1, and when the timer equals some set values that I choose, it turns on and off the output Y1, which is our lid shaker. I used many lines with compare statements to trigger our cylinders. For example, on rung 4, I say if the value of timer T1 is greater than or equal to 200 milliseconds, or less than or equal to 777 milliseconds, then turn on output C10, which is an internal bit in the PLC. On rung 21, I have all of these C bits used in the timer comparisons. If any of them are on or true, then the output Y1 is triggered on. If you noticed, I use compare statements using milliseconds and not seconds. Milliseconds works better for triggering the output on and off quickly. Next, I look for the timer to reach a higher timed value of 9,000 milliseconds or 9 seconds, and this triggers our second valve and opens the lid. Notice this line of code. It has to keep the output on until we tell it to turn off, which will let the lid back down. Now we want to make sure it is the last output to turn off, otherwise we could have a collision between the lid and our monster. I keep it on until 19.5 seconds. Last, I look for the timer to reach another set time, which is 1 second after the lid starts, to open and trigger our last valve, which pops up the head. This stays up for 7 seconds, then we turn each valve off in the reverse order, and the timer is reset. Once everything is reset, the system is ready for another round. As I always mention, there are many ways to achieve the same project, whether it be building the box, selecting pneumatic components, or writing the PLC program for the click. If done properly, they'll all bring you to the same finish line. And I'm sure if I were to program this project again 2 years down the road, I would probably do it differently. Today, this is how I did it, and it works great. I hope you're able to stop by Automation Direct's website and pick up a few parts and be on your way to creating your own automated Halloween prop or just something fun. Please, if you create something cool, let us know. We would love to see what you've created. Keep in mind, all of the products we have used in this system are products that Automation Direct sells, with the exception of our air compressor and the construction materials I used to build our crate. The tubing, fittings, wires, terminals, even the Teflon tape are all sold here at Automation Direct. So keep this in mind for all of your automation needs. Thanks for watching, and we hope to see you again soon.